Hello, Engineer Biringuel. We are from the Central Intelligence Agency or CIA and I am about to give you your secret mission. What's the situation? A 250 centimeters cube biological weapon has to be moved to another place via airdrop for inactivation. It is enclosed in a sensitive crystal brittle structure container that easily dissolves in acid. And as a leading engineer of your team, you are given a confidential task to make a protective device that ensures that the biological weapon container will not break when dropped. Good luck, Engineer Biringuel. This message will automatically be deleted in 5 seconds.
Oh no, what should I do? A potential biological weapon, which is a contagious disease like a virus, has been created. This dangerous pathogen can spore in skin and lungs, producing a 3-part toxin that is lethal and cause massive destruction and extinction on humankind when it gets released. I should be able to successfully create a protective device that can secure and make it intact until this deadly substance reaches its destination for deactivation by airdrop.
And as the construction and aerospace engineer, it is my role to assemble a team because it is my duty to lead the construction and launching of the protected device. But before that, it is just right for me to introduce them one by one. I have Megan, Joanna, GENESELA, and Ryn Villanueva as the civil engineers and they are in charge of the blueprint or the illustration of the design. Chrys, Gayle, CLEMENO as the theoretical engineer is the one in charge of the explanation of the scientific concepts where the device is based upon. Eugene DEMASU-AY as the material engineer, the one responsible for the inspection of the materials and their properties. Ryn Ysabel BARRIENTOS as the mechanical engineer and is the one who will check the final prototype if it will need improvement or can already be tested. And me, Engineer BERINGUEL, and Engineer BARRIENTOS will also take charge as the disaster and risk engineers who will foresee the outcome and overall analysis, and I will facilitate and supervise this secret mission.
Now that I have introduced them, it's time for me to call the civil engineers Megan, Joanne, and GENESELA, and Ryn Villanueva to ask for the blueprint of the protective device's prototype.
Our lead engineer needs our help with the prototype. We constructed the parachute that is connected to our cone-shaped prototype with yarn to restrict the device's fall, preventing the egg from flipping inside and slowing down the descent speed. The parachute can be as simple as a single sheet or as complicated as a multi-layer design. When the egg hits the ground, our constructed parachute adds air resistance, causing the egg to fall more slowly, preventing it from breaking. Drag is also employed to slow down the egg's descent and minimize the impact force in our egg drop design. We put strips of manila paper inside the prototype as caution for the egg so that something other than the egg itself absorbs the impact of landing.
The largest end of the egg has an area of air trap between the egg's two membranes. This area space forms when the contents of the egg cool and contract after the egg is laid. Upon impact, the heavier spherical yolk continues moving towards the ground. The compression of the air space acts like an airbag for the egg's valuable contents. Therefore, constructing an artificial cushion inside our prototype will also help absorb landing impact. In order to maintain balance, we constructed a cone-like prototype since the egg will remain at the rest or move at a constant rate. The cone-shaped prototype is formed by using a yarn connected to the point where the egg is balanced and safe inside the device.
As I have already seen the prototype, it's time for me to consult the theoretical engineer Chrys, Gayle, CLEMENO on the scientific conceptual theories that we will be observing.
We must first comprehend gravity, velocity, acceleration, and Newton's law of motion. The biological weapon will increase in velocity and acceleration until it hits the ground, and it will infect people if it drops without any protective covering or mechanism. Gravity is a force that operates on an item and pushes it towards the earth. Newton's first law of motion states that an object at rest will stay at rest, and an object in motion will stay in motion until acted on by an unbalanced force. In our experiment, gravity and air resistance act on the object. According to Newton's second law, the acceleration of an object is directly proportional to the net force acting on it and inversely proportional to its mass. According to the third law, every action has an equal and opposite reaction. It applies because air resistance slows down the object coming down. After all, the air resistance of an open parachute increases the cross-sectional area of the falling object. Once the thing drops, air resistance overcomes gravity's downward force, changing the net force and acceleration of the falling device, hence slowing the object's speed.
Now that we know what applicable theories to anticipate, it's time for me to seek the approval of the materials engineer David Eugene DEMASU-AY if the materials can pass or not.
The materials we use for this experiment are a 1 meter yarn, 1/2 manila paper, 1 meter masking tape, and an egg. The yarn has flexible and elastic properties which will secure the container and also act as the string to the container's parachute. The yarn also has a torsional rigidity to which the fiber of the yarn is resistant to twisting while in the air. The yarn's main purpose was to connect the parachute and the container. The manila paper is made of semi-bleached wood fibers which makes it as strong as craft paper. The manila paper was used to avoid spilling the biological weapon into the air and at the same time keep it in place. The manila paper was also lightweight, which makes it easier for the parachute to carry. It also has a lower air resistance, making it a good material for the parachute. It was also used as a cushion to protect the biological weapon upon impact to the ground. The masking tape was used as an adhesive to stick the materials together. And finally, for our biological weapon, we used an egg. An egg is fragile and could break upon a strong force of impact. Due to this, an egg is ideal for our makeshift biological weapon.
Since the materials are now approved, it's time for me to construct the prototype. But before that, let's hear from the mechanical engineer, Ysabel BARRIENTOS.
After taking careful consideration, I suggested putting crumpled manila paper between the biological weapon inside the cone and taping the strips of the manila paper at the top, which was folded and formed into an X shape to lock the crumpled manila paper and the biological weapon in it, preventing it from going out of its protective device.
Now that all is settled, it's time for me to construct the prototype as the construction engineer.
In constructing the prototype, I first prepared all the materials needed such as the 1/2 manila paper, 1 meter yarn and tape, and the biological weapon, which is the egg. I started making the protective device by folding the 1/2 manila paper into 2 halves and separating it, as these 2 divisions will be used for 1, the cone, and 2nd, for the parachute. After doing so, I cut a curved shape on the edge of the first divided manila paper, as this will be utilized for the making of the cone, in which the biological weapon will be securely locked. Once I finished cutting it, I rolled it into a cone shape and sealed it with the tape. Afterward, I wrapped it again with the second divided manila paper and with the same process to assure its safety and security. Once done, I tried to place the biological weapon inside, which is the egg, to check if it fitted tightly. Just to add, I taped the egg for fastening. And using the excess strips of paper that were cut, I crumpled and placed them below and above the egg to be more protected. And since the container of the biological weapon is okay, I proceeded in the making of the parachute, in which I began by cutting a half portion of the remaining manila paper to be utilized for the X lock of the container and the parachute as well. After cutting it, I rolled it firmly into 4 thick strips of paper and taped it to hold together.
And because I'm also the aerospace engineer, I should be the one to conduct the alpha testing of our protective device before it can be officially used. Let's go check it now.
In the first trial of the alpha testing, the protective device was dropped at 1 meter height. And for the second trial, the height was increased to 2 meters of elevation from the floor. And for the last trial, the level was increased to a height of 3.7 meters from the ground. After performing all 3 trials, I opened the protective device to check the biological weapon. Gladly, it was still secured and intact.
With the help of engineers in each department, we have successfully created a prototype for a protective device to transport a biological weapon to another location. The trials conducted showed how the biological weapon had safely landed without breaking out of its protective device.
Having said that, the success of this mission resulted in a safer welfare because if this biological weapon gets exposed, the toxin inside it will be released and will surely cause global or mass destruction. And as responsible engineers, we did our best to carefully plan this out and create a protective device that can be compatible with the weapon and can surely secure it. The secret mission was conducted to prevent the worst to happen and to assure the safety of each and everyone. With the result from the alpha testings, therefore we conclude that the mission impossible turned possible is a success. Thank you.